Welcome to this video. In this video, we're going to be going through the basics of organic molecules for organic chemistry. This will be our first video for organic chemistry. Look out for other videos coming up. So let's get into it. What is an organic molecule? Let's start there. An organic molecule is a molecule that contains a carbon atom. So let me show you an example of a organic molecule. We're going to use 3 carbon atoms. I'm going to combine the 3 carbon atoms. Every carbon has to have 4 bonds. That's a rule that you need to remember. So I'm going to have 1, 2, 3, 4 bonds and fill the rest up with hydrogen. So 1, 2, 3, 4 bonds. So these 2 bonds would have hydrogen. There's 1 bond here for this carbon, and 2, 3, 4. So I'm going to add the hydrogen atoms onto that carbon. This carbon molecule is called propane. Now propane has 3 carbon atoms and 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. Here is a 3D representation of propane with the white circles or the white spherical objects representing the hydrogen atoms and the gray spherical objects representing the carbon atoms. And the lines in between them representing the bonds between the hydrogen and the carbon and between the carbon atoms. So if we go back to this structure over here, we have the first carbon atom with 3 hydrogens on it, 1, 2, 3. Second one with 2 hydrogens on it, second carbon, 1, 2, and it's bonded to the other carbon and the other carbon atom, and the last carbon atom has 3 hydrogen atoms on it. They all have 4 bonds, so 1, 2, 3, 4 for the first carbon, 1, 2, 3, 4 for the second, 1, 2, 3, 4 for the third. And the hydrogen atoms only have 1 bond each. So 1 bond, 1 bond, 1 bond, 1 bond, 1 bond, 1 bond, 1 bond. It's only carbon atoms that have to have 4 bonds each. This representation of propane is known as the structural formula. There's another way of representing a more simplified version of the structural formula, and that's known as the condensed structural formula. And it's represented like this: CH3 bonded to CH2, which is bonded to CH3. So I have that CH3, which is 1 carbon atom with 3 hydrogen atoms, bonded to CH2, which is the carbon atoms bonded to 2 hydrogen atoms, and then the CH3 at the end, which is 1 carbon atom bonded to 3 hydrogen atoms. And it's assumed that each bond is between the carbon atoms, not the hydrogen atoms. One more formula we need to know that represents the molecular structure itself is the molecular formula. And this one is simply just the number of, in this case, carbon atoms and hydrogen atoms. So how many carbon atoms do we have? We have 3. How many hydrogen atoms we have? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And that's simply our molecular formula for propane. So that these are the 3 different representations we have of a molecule. You have the structural formula that indicates all the atoms and how they are bonded together, and the condensed structural formula, which shows the bonds between the carbon atoms and how everything else is bonded to the carbon atoms, and the molecular formula, which simply shows the number of atoms there are in the molecule itself. So going back to the structural formula of propane, you'll see that the only atoms involved are carbon and hydrogen. And there's a name for atoms that only contain hydrogen and carbon. The name for these molecules are hydrocarbons. Hydrocarbons are organic compounds that consist of hydrogen and carbon only. So, if we look at our propane again, we realize that it only consists of hydrogen and carbon. And there are three types of hydrocarbons. The first is alkanes, the second is alkenes, and the third are alkynes. Let's go through the difference between the three. Again, using our propane as an example. Remember, we're talking about hydrocarbons. So you need to keep in mind that these are molecules that contain carbon and hydrogen only. But what's the difference between an alkane, alkene, or an alkyne? Well, the alkane contains single bonds only between carbon atoms. If we look at the propane molecule again, we see that there's only one single bond between the carbon atoms, and therefore this molecule is an alkane. And when naming these molecules, we have the suffix "ane" at the end of them. So remember, this molecule is called propane, or this "ane" part at the end of the name propane indicates that this is a hydrocarbon called an alkane because it has the suffix "ane." So then I wonder if you can guess what an alkene is. An alkene is a hydrocarbon that has at least one double bond between the carbon atoms in the hydrocarbon chain. So what is a double bond? A double bond is simply two bonds between atoms, in this case between the carbon atoms. For it to be an alkene, it has to have at least one double bond between the carbon atoms in the hydrocarbon chain. So between the carbon atoms, there's a double bond. That's how you identify an alkene. But something is wrong here. This carbon, for example, has 1, 2, 3, 4, 5 bonds. It should have 4. And this one also has 1, 2, 3, 4, 5 bonds. That's because we added an extra bond there. And that can't happen. Each carbon has to have 4 bonds. So a hydrocarbon of this nature would have 2 bonds on one carbon here with that double bond, so that there's 1, 2, 3, 4 bonds. We need to make sure there are 4. So instead of it having 1, 2, 3 hydrogens, it would have 2 hydrogens to fill up those 4 bonds. And this one would have 1 hydrogen to fill up the 1, 2, 3, 4 bonds, because it has this carbon with a double bond and this carbon with a single bond. So there's only one space for hydrogen to fit into this molecule here. So this is a new structure. It's no longer propane. It's no longer an alkane. It's an alkene. So what is it called now? It's called a propene. Alkenes have the suffix "-ene" at the end of it. Unlike the propane that has the suffix "-ane", alkenes have the suffix "-ene". I'll be seeing a pattern there: alkane, ane, alkene, ene, and therefore an alkene that has at least one double bond between carbon atoms will have the suffix "-ene" in its name. In this example, propene. So now we're just left with alkyne. I might have lost some information there, but let's continue. Last but not least is alkynes. Alkynes. I'm sure you can recognize the trend here. An alkyne is a hydrocarbon that contains at least one triple bond between the carbon atoms in the hydrocarbon chain. So there'll be at least one triple bond between the carbon atoms. There has to be 4 bonds. That means there won't be a hydrogen bond there or a hydrogen bond there. And this is an example of a propyne. Propyne hydrocarbon. So there you have it. That's the difference between an alkane, alkene, and alkyne. At this point, you might be wondering where the word prop comes from. And how would I know when to use the word prop? Well, let's dive into the nomenclature of organic molecules. The prefix that we use when naming a molecule is dependent on the number of carbon atoms in the longest chain of that molecule. So, what does that mean? Let's say your molecule had 1 carbon atom, then its prefix would be meth. So you have like methane, or you can only have methane because you can't have a double bond or a triple bond because you'd need another carbon atom for that. Since you only have 1, it can only be methane in the terms of a hydrocarbon. So let's say you had 2 carbon atoms. Let's say you had 2 carbon atoms, and the prefix for that would be eth. So you have ethane. For the hydrocarbons, you'd have ethane, you'd have ethene, and ethyne. We've already explored 3 in our earlier examples, and we had prop. That's where the suffix prop came from. For 3 carbon atoms. So we had propane. For propane, we explored what propene looks like, and we explored what propyne looks like. So I'm sure you're getting the idea. For 4, we have bute. For 5, we have pent. For 6, we have hex. For 7, we have hept. And for 8, we have oct. There's still a lot more, but usually don't go more than 8. So we'll leave it at oct. Most of the examples usually explore maybe 1 to 5 carbon atom chains. But 1 to 8 should be sufficient for all your questions. Let's wrap this video up here. This should give us a base idea on how to name certain formulas, how the structural formulas look, how the molecular formulas look, how the condensed structural formulas look. And as we go further, if we have this foundation, it should be easier to apply as we go forth. So take note of the things, rehearse them, learn them, understand them. As we move on to the next videos, look out for the next videos. It should be more insightful into the things we need to know in organic chemistry. Bye.